Thank you, Alan. Hi, everyone. My name is Bogdan-Andrei Iancu, and I'm from the OpenSIPS project. And yeah, in the last days, we heard a lot of stories, about companies with different visions, showing us their experience when it comes to the telecom world. A lot of data about the consolidation that is taking place, about all the acquisitions and everything. So basically, we get a pretty good idea on how the things are progressing in the area. But we don't have to forget that all these actually rely on a lot of technology, right? So without the technology, the underlying technology, basically nothing will be possible. So this is actually the topic of my presentation. It's on the technology part that's mostly used in the telecom world. So first, quickly, just what OpenSIPS is. We call it a multi-purpose SIP server. Basically, you can do more or less everything when it comes to SIP signaling, because it's a very flexible, configurable. So basically, you program what you want to do. You can program it to act as, for example, SBC, as a soft switch, or maybe you want like a PBX or whatever. And this is thanks to configuration language and also to quite a huge number of modules that actually provide a lot of functionalities and support in different areas, like SIP area, in AAA area, routing, and a lot of other capabilities that you just merge and use directly from the configuration. Again, this is kind of a programming, so basically we say what you can do is just limited by your own imagination and of course your programming skills. Besides this kind of a flexibility, one of the strong points of OpenSIPS is also the huge throughput that it's able to handle as a single application. We are talking about thousands calls per second, tens of thousands, maybe 100,000 during tests, simultaneous calls through the system. So more or less, this is what OpenSIPS is, and the most important is it's an open source project. So it's not only open source in terms of coding, so you have access to the code, but we have a community and we have a good interworking with the community in terms of listening to the needs of the community, in terms of what needs to be done, in assisting with help, in troubleshooting together with the community when it comes to the problems. So yes, we have and we do maintain a good, let's say, cycle with the community. Roughly like 2 months ago, we had our annual OpenSIPS Summit. It's the event with the community, and we are happy as today here to be back like in a real event, to put behind us the online approach. Yeah, and in each year we do have a major release for the project, and we have this kind of a policy that each major release tries to focus on a certain specific, in order to get a more consistent, let's say, delivery for our users or to the community. Basically, in each year we collect information from, let's say, the industry needs, so basically what people using OpenSIPS need. We collect ideas from the community. Of course, we put from our team side what we also need, because we are also using OpenSIPS, or what we think would be nice to have in OpenSIPS. So we put everything in a pot, and then boom, we say, okay, this year we will do that. So we had the years focused on service creation, so more in the class 5 area. We had years when we focused on integration with other softwares in the area, and so on. And this year, the focus was actually on the instant messaging. And again, I'm talking about instant messaging from the SIP perspective, so in the SIP world. Why? Well, probably doing SIP will know that actually, you know, everybody when saying SIP say, oh, wow, calls. So basically, 90% of SIP it's about calling. But as protocol and in terms of capabilities, you can do also presence and also instant messaging. And in instant messaging is some kind of, you know, the small kid in the family over here. So we said, yeah, it's time to look a bit into, not because, okay, yeah, it's a bit negative, but because instant messaging is actually an important part when it comes to the IMS ecosystem, especially about the rich communication systems. And also in the unified communication. So you cannot actually talk about unified communication without taking into consideration the instant messaging. So all these were like, okay, good reasons to say yes, we need to look into and to say, okay, what can be done in order to improve what OpenSIPS can do in terms of the instant messaging side. Basically the big idea, the big change when it comes to the instant messaging, it's how you handle it in terms of the protocol. So far, you know, old traditional way, it's based on the RFC 3.428, which is actually, you know, the SIP message, a simple method, and that's called the instant messaging in page mode. So basically each message, it's standalone, there is no relation, there is no session, so basically you cannot correlate messages together, and that's it. Even if you have a logical kind of a conversation between two parties, again, each message is by itself. So looking at the SIP layer, you cannot put together, you know, the messages in order to say, yeah, that's actually a logical discussion. So by logical discussion, meaning that, okay, I can do something, extract more information, I can do more services because, okay, I have kind of a session, you know, I can put all things together. So they are just a bunch of individual messages, so a bit difficult actually to build on top of something like that. So yeah, that's actually the transition to the new approach on the instant messaging, which is the session mode or the MSRP, the message session relay protocol. So there are a bunch of newer RFCs comparing with the old message method. Where, as the name says, okay, the whole communication, the whole instant messaging, it's actually part of a single session. So you can use, I mean, you use SIP, the typical invite stuff, like, you know, like creating a call, actually a session, in order to create a chat, a messaging session between the parties. The SIP side here, it's, you know, as session, initiation protocol, it's just for establishing and managing the actual session. But the payload, so the messaging itself, is into the MSRP. So like you have in the regular calls, the SIP negotiating the session, and then you have the RTP carrying the audio part between the endpoints. In a similar way, here we have SIP setting up the session, and then the MSRP here carrying the messages between the endpoints. So the main advantage of this approach is the fact that, okay, you have a session, and in this case, you know, the whole conversation, it's linked together, and then you have a context. So once you have this context for the whole discussion, you can create more services on top of it. For example, if you want to do like transcripting for the conversation, if you have like individual messages, it's very difficult to, you know, to trace, okay, which messages actually do I have to transcript as part of this conversation. Once you have a session, it's much easier because, okay, you have everything. Or you want to do some, let's say, extract some analytics, or to do some, you know, some analysis of the discussion. Okay, once you have the session, it's easier to put everything in a context. And besides the fact that you can do a lot of nice services on top of this, when it comes to unified communication, then suddenly, you know, we already had the audio and the video part as sessions, and then boom, you have also the messaging as a session. So it's much easier to integrate in UC systems, because you know everything it's leveraged as a session. So yeah, that's the big picture, we call it, about the MSRP support we have in OpenSIPS 3.3. And because we said, you know, typically we said, okay, yes, let's focus on something, like in this case on the instant messaging with MSRP. We try to, let's say, address this on multiple layers in OpenSIPS. So basically, what the whole MSRP support consists into, everything it's in the middle. We have the MSRP relay, so basically the ability just to interconnect parties, exchanging MSRP. So basically that's the basic support that you need, and then around it, we said, okay, we need more functional MSRP-related functionalities in order to create a fully functional and usable ecosystem for this. And we said, okay, we still have a bunch of SIP clients supporting only the traditional SIP message. So what do we do with them? Okay, we need to integrate. So we said, okay, let's build an actual gateway to translate from SIP regular message to MSRP. Just to help, you know, the grandma phone also. Then we have in the IMS area, we have the RCS, which basically it's also, you know, to a certain point MSRP. But it comes also with a lot of particularities in terms of negotiating capabilities between the endpoints and so on and so on. So we said, okay, we need a kind of RCS gateway, basically, just from the OpenSIPS perspective, to be able to understand and help with handling all the capabilities exchanged between the endpoints. Then moving into the unified communication area. In the previous versions, we already have okay, at that moment, a call center. Basically, it's an engine, like a queuing engine and distribution engine for agents in OpenSIPS, and we said, okay, it's time to upgrade and also add the ability to handle the messaging session. So basically, that's a contact center, not a call center anymore. And in a similar way, why not having kind of a multi-chat conference with OpenSIPS, so where you have different devices connecting with the MSRP and emulating the experience of a chat room with APIs and everything to control. So we identify multiple points where actually we had to do work into OpenSIPS in order to add this MSRP relay. So translating that, you know, big picture into what we did in terms of development, everything relies actually on implementing the MSRP protocol into OpenSIPS. Basically, the MSRP, it's not so complex, but it's not kind of a really simple protocol. So it's actually it's a protocol by itself. So we had to add the ability of OpenSIPS to handle this protocol, and then internally expose an API for a middleware in order to implement more, let's say, high-level kind of support when it comes to MSRP. One of it was the MSRP relay, so basically to manage a session between the endpoints, to relay the traffic between various endpoints. And this relaying, okay, it sounds simple, it's relay, but actually it takes in consideration some authentication factors and so on and so on. So it's a bit, it's more complex than a simple relay. And also at this level, we have the MSRP user agent, so basically a kind of an endpoint for MSRP, that we can use in conjunction with the SIP. So basically it's a SIP plus MSRP user agent. So basically the ability to either terminate, either start SIP plus MSRP sessions. And this ability of acting as a user agent may be used directly from the OpenSIPS script. So okay, when you have an incoming call with MSRP, you can handle it in the script, like accepting it and things like this. And through external APIs, you can also interact with, we'll see later, with with the external entities in order to control the UA. And also there is an internal user agent, so internal API of the user agent, so which is used by high-level modules like the MSRP gateway, because at the end of the day, the gateway, it's on one side is an MSRP user agent. On the other side, it's either SIP message, a simple SIP message, either a simple API to the outer world. And still on the to-do list, on top of the external API will be the MSRP conferencing, so the multi-chat conferencing. So yeah, let's move into the unified communication. So how this all the work we did here fits into the UC world. So yeah, first of all, as we said before, unifying, we need to have something to unify. So in this case, the first need is to be able to, let's say, bridge a lot of non-session chatting to MSRP, and then we can unify all the services. So as mentioned, we have the SIP message to MSRP, basically the ability to handle and to dynamically create MSRP sessions based on regular standalone SIP messages. So how this works, we have let's say the SIP client with messages, sending SIP message to the gateway. This will automatically start the SIP layer in order to create the MSRP session, and then actually push the content as to the MSRP channel. After that, once the session is up, all the new messages are simply sent, and both directions. And okay, we need also to take care of ending the session. Of course, on this side, because there is no actual session, just a logical concept based on inactivity timeout. Okay, we can trigger the ending of the session on the MSRP side. Or if there is a byte here, basically you don't have to do anything on the other side. And OpenSIPS here is taking care of this, let's say, logical mapping. So basically looking at, okay, who's the sender, who's the destination, and we're looking also at the device identity, like based on the contact, in order to try to do the mapping. So there is a logic to try to say, okay, this message belongs to this session. And you have the possibility from the script level to do also this, to do your own mapping between the SIP and the message and the MSRP. In a similar way, we can have the OpenSIPS exposing for the MSRP UA an API. So whatever external application can actually interact with the MSRP with other endpoints. And basically on OpenSIPS exposes an API with events to get notification of what happens on the MSRP side, or with commands in order to instruct OpenSIPS what to do, like, okay, send a message, start a session, and so on. Again, just a simple example. Through the commands, you can start the session, and then you can start sending messages. When you have an incoming message, you get an event notification of, okay, there is a message to handle. So you can build an external application completely unaware of the SIP and MSRP layer in order to push messages through MSRP on the SIP side. Now, quickly going into the migration from call centers to contact center. Basically, the whole idea was to add support for messaging, for chatting, and this is a bit tricky because comparing with the voice, where an agent can do only one voice call at a time, when it comes to the messaging, an agent can do multiple chats in the same time. So you have the complexity of managing multiple parallel channels, but in the same time you cannot do audio and chat in the same time. So things are a bit complicated with this. And yeah, that's the typical architecture. When you receive audio or chat calls from different sources, and then you distribute to different kind of agents. Agents may have different capabilities in terms of supporting either voice, either chat, maybe both, with different, in terms of MSRP, with maybe with different capacity, like 2, 3, 4, whatever simultaneous calls. But the challenging part is about the call distribution algorithm, because you can end up in a different scenario when you have starvation for the voice calls, because, okay, MSRP allocates one, let me just go to actually to the, it's more relevant, yeah, with agents supporting both. So if you have multiple MSRPs, you actually can lock all the agents into chatting, so you don't have any, like in this example, you don't have any channels left for the audio. Even if you have calls, agents with, let's say, with calling capability, just because you evenly distributed all the chats, you create a starvation for the audio side. So this balancing, it's fair from loading the agents, but may leads into starvation. And a different approach we have is to trying to load as much as possible an agent, like in terms of chatting, so to reserve, if possible, agents for the audio call. So basically the same scenario. In this case, all the MSRPs you see will go all the time to the first agent, because that agent is already into the MSRP stuff. So then I can actually also handle the audio calls. But it's not fair from, let's say, from load perspective, because this guy is idle, you know, and the other one is doing a lot of calls. Yeah. So if you are not happy with the algorithms that we have built in, you have the ability to control the call distribution through an API. So basically, you can check through the API what are the calls in the queues, what are the statuses in terms of load of the agents. So you can decide, okay, which call goes where. So in that case, you can do your own thing in terms of. And quickly, just one slide. It's actually 2 slides about the IMS. It's mainly about the RCS, where there are a bunch of protocols, and we said, okay, yeah, happily we do support all of them, but the missing part is actually handling the RFC capabilities, which are in the SIP protocol. And in order to, to make life easier for people implementing something like that with OpenSIPS, we put together some tutorial showing you how to handle, from the OpenSIPS script, all the list of capabilities, like looking into, removing, and so on and so on. So just to get in the middle of RCS capability negotiation when it comes to the traffic. And now that we opened the Pandora's box on this side, okay, yeah, the roadmap, we are looking into end-to-end encryption for the MSRP chat, so that would be one of the next steps. People are already asking about recording or transcripts for the MSRP chats, or kind of a real-time interception, so without looking into. Already mentioned the multi-chat support, or being able to extract different kind of control events from the MSRP, because the MSRP, just to say, it's not only about transporting the instant messaging, so the message itself, but also a lot of things, control events like, okay, typing or delivered, and stuff like that. So also part of the MSRP. So these kind of events may be extracted and exposed to the OpenSIPS. So, Alan, hopefully I got in time.
Excellent. No, that's great. Thank you so much. I'm sorry we're racing through, but he's here, so you can chat.
I fully understand you. Don't have to explain.
So Aaron, come on.